Hello, my name is Maddie, and today I'll be showing you how to assemble and use the grip sensor from our work. First, I will show you all the tools and equipment you will need to build the device and to use it, and then we will go through a step-by-step tutorial on how to assemble it. So starting from the right-hand side, you will need a soldering iron and a few other soldering equipments that can make the soldering process easier. Of course, you will need the 3D printed parts. Here I show all the parts that we have open sourced, but today I will be using the sensor main body, the load cell mount, and we will use two of the load applicators to calibrate the grip sensor. So putting these back. You can, of course, 3D print the other parts as well, but that's not necessary to get the device started. Now you will need to decide on how you want to calibrate the grip sensor. Here we show two ways. One way is to use a kitchen scale and apply different loads to the to the grip sensor while it's on the kitchen scale. Or you could also apply known weights, known calibrated weights to the device to calibrate it. The next thing you will need is a pair of two sets of pliers. Doesn't really matter what type. Here we had a needle nose and regular set of pliers. And then lastly, you will need the electronic components. We have an HX711 amplifier, an Arduino Nano, a small breadboard. If you have a bigger one available, you could use the bigger one. There are also ways to not use a breadboard at all if you would like, but to keep it simple, we use it. You will need the load cell itself and a threaded M3 rod and three M3 nuts and the USB cable to connect the Arduino to your computer. All right, with that covered, the first step would be to solder the load cell to the HX711 amplifier and subsequently the HX711 amplifier to the Arduino. So the first step is to solder these connection points to the HX711 amplifier. And to do that, first place the pins on the breadboard. And while we're only going to be soldering the right side, it makes it easier if you place a few connector points on the left hand side as well. This makes sure that the board is level uh, when you're soldering. So technically I could remove the breadboard now and put it back. Again, make sure that the pins on the right side line up. All right, now that we've ensured all four pins are positioned correctly, we will begin soldering them one by one. Now, I do want to point out that in case you're worried or don't have experience with soldering and are worried that you may not be able to do this, some manufacturers do sell HX711 boards that have the connectors pre-soldered on, so you could use this to skip the soldering step. Next step is to take the Arduino, and because this is a small breadboard, you will need to bend a pair of pins so that it sits lower. You can pick pretty much any pin as long as it's D5 or higher on the digital side and A4 or higher on the analog side. So let's pick A3 and D6. And what you want to do is to grab your needle nose pliers, make sure you're on the right pin, and just bend it outwards like that. Same thing, make sure you do it on the one opposite to it. So you grab that, you bend it outwards like that. So this is what we're trying to get. And now the Arduino will fit onto the breadboard. We can go ahead and place the HX711 amplifier on the breadboard as well. So now we need to connect the load cell to the amplifier. On the left hand side of the amplifier, there are a number of pins. We will be using pins E plus, E minus, A minus, and A plus. The E plus we will connect the white cable to, the E minus we will connect the yellow cable to, A minus will have the red cable and the A plus will have the black cable. This will be shown on the screen as well. So we will just go ahead and solder these one by one to the HX711 amplifier. And now we're done with the soldering iron. So we have connected the load cell to the amplifier. Now we need to connect the amplifier to the Arduino. If you look at the right-hand side of the amplifier, there are 4 pins. They're labeled GND, DT, SCK, and VCC. This is where you can use the jumper cables. To make it easier, you could use color-coded jumper cables. Black is typically used for ground, so we'll connect that to the ground. And on the other end, we'll also connect that to the ground. And red or white could be used for VCC. And we connect that to the 5-volt pin of the Arduino. Now for the next 2 pins of DT and SCK, we want to connect DT or D out to pin 3 and the SCK to pin 2. Okay, now we have the connection. You could continue to assemble the device, or first, I would recommend that you just connect the Arduino to your computer, make sure it works before you start assembling everything. And to do that, first, you should pull up the GitHub repository and go to the grip sensor code folder, Arduino. You could pick Calibrate if you want, open that up, and then pull up the Arduino IDE, which will open a new sketch for you. Copy the code from the calibration, move it over. Next thing you need to do is to go to Tools to select the port your device is connected to. I have not plugged in my Arduino yet, so it doesn't show. Now the lights start blinking on the Arduino. Here I go to Tools, and we see that the port I can select. If this is the only USB device you have connected, it will be the only option. But if you're not sure which one it is, what you could do is plug your device out, go back to the main page, click Tools, look at the ports, see what's available, and then plug your device in and go to Tools again and see what is the new port that you could select. Here I only have that one, so I will select it. Because I've done this before, it auto detects that it's an Arduino Nano, but what you could do is it would say unknown device. You could select it and you could select the board. Another way you could do it is to go up here and click boards and Arduino AVR boards and click Arduino Nano. For the processor, most new Arduino Nanos will use the Admega 328P, but some older version Arduinos and perhaps knockoff brands may use the old bootloader. So if you have trouble programming the Arduino, this might fix the issue for you. All right, with that connected and with the code copied, one other thing we need to do, and just for you to know, if I were to upload this code right now, I would get an error because we have not installed the HX711 library yet. To do that, you can click here and search HX711. The first one is good. You can download install the latest version. So you click install, you can close this, wait for it to finish installing, successfully installed. You can close these two. And now if you upload it, it should go through. And again, if it does not go through here and you get some errors, of course, Googling your error will almost always find a solution because many people run into these kind of issues. But typically, it could also be you may have picked the wrong board, the wrong port, or the wrong processor. All right, now that the uploading is done, we can test the device. I will say again, if you get errors here, make sure to check your connections, that you connected the VCC to 5 volts, the GND to the ground, or the GND port on the Arduino, and that the DT and SDK are on the digital D2 and D3 pins of the Arduino. Sometimes you may have swapped them around, so if you're not getting any output, you could pull these out and replace swap them around and see if that works. But here it worked fine. So now what we can do is actually look at the output from the sensor. To do that, you click Tools and then Serial Monitor. And here it will output the reading from the device. It's reading 0, but if I pick it up and apply some force, so as you can see, I'm applying force and it's measuring that. All right, so now that we know the device works, what we want to do is to assemble everything together. All right, so now we're going to take the sensor main body, the load cell mount, and the M3 threaded rod, and the three M3 nuts. First step would be to embed one of these M3 nuts on the end of the sensor main body that has the space for it. For this device, I've already placed that in and actually placed a little bit of glue around it to make sure it's secure. But to show you, here's another device that does not have the M3 nut in there yet. What I like to do is to take the rod, put one of the nuts on the end of it, thread it a little bit, and then place it inside, and then just push until it fits firmly in there. And you can now see that that nut is securely in. And now what we will do is we need to use these two nuts to create a secure end for this rod. And so first thread one of these nuts through and thread a little bit past, thread the second one through, pull it down. Now you want to, with your hand, bring these two together and try to get them as tight as you can with your hand. But that's where the pliers come in. You want to hold the bottom nut with one set of pliers and then twist the top nut tighter into the lower one by maybe a quarter of a turn or so, just so that they're fit together and they don't want to come undone. Then you are going to put the load cell inside the load cell mount. And just to note that there is two ends to this, you want to feed it through the end that has that extra pocket for the load cell. You pass that through, you pass the threaded rod through the hole of the load cell and through the mount and through the sensor body and thread it so that it's coupled against the nut we placed on this end. And so you can also thread it on this end if you'd like. You could make this as tight as you would like, but you want to at least have a secure connection between them so that the load cell mount is not moving around. So this is already pretty good. All right, now that we have the full assembly, we can calibrate the device. For the calibration process, it is up to you what method you want to use and depending on what devices and tools you have access to. Perhaps the simplest one is to use a standard kitchen scale. And we will apply load to the device on the scale and compare the sensor output to the reading of the scale. Of course, you can use more sophisticated methods. For example, in our work, we used an Instron machine, which has high accuracy and high fidelity in applying different levels of loads. But this method could also work depending on the level of accuracy you want from the device. So with the kitchen scale, what I will first do is take these two load applicator plates and place one on the top and then another one on the opposite load plate. This just gives us a flat surface to apply load on. Okay, now we can click on serial monitor and we'll get the sensor output. It's right now saying the output is in pounds, but of course you can change this to whatever units you want. And in fact, I will change it to grams because the kitchen load cell I'm using is in grams. And the calibration factor is what we will change to calibrate the sensor. So let's close this first. Come down here to where it says pounds. Change it to whatever units you want. So let's say grams. Upload that to the Arduino. Okay, now we can do serial monitor. And now we're getting 0 grams. And if I apply a known weight of 1,000 grams, for example, I'm getting 5 grams. And so clearly I need to adjust the calibration factor to get the right output. And so to do that, what you can do is you can take your known weight, divide it by the output of the sensor, and then take that number and divide the calibration factor that it's currently set to with that number. And so 1,000 divided by 4.3, 4.4 is around 222. And then 7,050 divided by 222 is around 32. So now that we know that, I'm going to close the serial monitor and go up to the calibration factor and set it to the number I just calculated, around 32, and upload it. Okay, now that I've uploaded it, I can go to serial monitor again. And here we see it's pretty much reading 0 grams. And now if I apply my known weight again of around 1,000 grams, we see that it's pretty close, but of course I approximated the calculation, so this is where we can go in and tweak this even further. So what you can do is type in plus in the message and press enter, and you can see it will slightly adjust the calibration factor. And so that's already pretty good, reading basically 1,000 grams with some expected error. If we want to make sure this calibration factor is right, what we can do is remove the weight and apply a different weight. So here we go. I am now applying 200 grams, and we're roughly reading 200 grams. We're reading a little bit higher, so perhaps we could reduce the calibration factor by a bit. So that's roughly 200 grams. And the other thing you could do is to apply continuous amounts of weight, which is what I try to do here. So if I apply some weight, so right now applying around 200 grams. Let's increase that to, yep, 580 grams, and we're roughly getting 550. And again, you can further tweak this number with all these data points, but if I apply even more weight of around 1,000, we're getting 1,000 as well. Now we have a working device, so what I can actually do is remove these load application plates and remove the kitchen scale. And now I can apply force myself. And you can see how much force in grams I am applying. Of course, I could have done this in newtons if I wanted to, or kilograms, but you can see as I modulate my grip force, doesn't matter where I apply it. I apply force on this end, I apply force on this end, at both ends. Uh, we continue to get the reading. And so with that, we've covered how to assemble, calibrate, and use the grip sensor device we proposed. And you can use this in your projects. As you can see, the assembly process is fairly straightforward, and it's a very cost-effective way of measuring participant grip force. Thank you for your time.